pressure. Every object exerts a pressure because of its weight. Pressure exerted by a liquid at rest is defined as the thrust exerted by the liquid per unit area. Thrust exerted by a liquid is the force exerted by the liquid perpendicular to the surface of the liquid in contact. Pressure is equal to thrust over area. That is, P is equal to F over A. Its SI unit is Newton per meter square and the dimensional formula is ml minus 1T minus 2. Variation of pressure with depth. Suppose a fluid is at rest in a container. An object is submerged in the fluid. The fluid exerts a force on its surface. This force is always normal to the object's surface. Consider 2 points 1 and 2 on the object. The height is h between these points. P1 and P2 are the pressures at points 1 and 2 respectively. Consider a cylindrical element of fluid having area of base A and height h. As the fluid is at rest, the resultant horizontal forces should be zero and the resultant vertical forces should balance the weight of the element. The forces acting in the vertical direction are due to the fluid pressure at the top, P1A, acting downward, at the bottom, P2A, acting upward. If mg is the weight of the fluid in the cylinder, we have P2 minus P1 times A equal to mg. Now if ρ is the mass density of the fluid, then the mass of fluid Bm is equal to ρv, which is equal to ρha, so that P2 minus P1 is equal to ρgh. Pressure difference depends on the vertical distance h between the points 1 and 2, mass density of the fluid ρ, and acceleration due to gravity g. So the liquid pressure is directly proportional to the height of the fluid column, or liquid pressure increases with depth. Hydrostatic paradox. The liquid pressure is the same at all points at the same horizontal level, that is, at the same depth. 3 vessels A, B and C of different shapes are connected at the bottom by a horizontal pipe. On filling with water, the level in the 3 vessels is the same, though they hold different amounts of water. This is so because water at the bottom has the same pressure below each section of the vessel. Gauge pressure. Consider a cylindrical element of fluid base area A and height h, whose one surface is open to the atmosphere, on which pressure applied is the atmospheric pressure P0, and pressure on the lower face inside the fluid is P. Then P is equal to P0 plus ρgh. Thus, the pressure P at depth below the surface of a liquid open to the atmosphere is greater than atmospheric pressure by an amount ρgh. The excess of pressure P minus P0 at depth is called gauge pressure at that point. Pascal's law. When a force is applied to a contained incompressible fluid, the pressure increases equally in all directions throughout the fluid. 2 pistons, 1 and 2, fit into 2 glass cylinders filled with oil and connected to one another with an oil-filled pipe. When a downward force is applied to one piston, then the force is transmitted to the second piston through the oil in the pipe. From Pascal's law, P1 is equal to P2, where P1 is the pressure exerted by first piston and P2 is the pressure exerted by second piston. But pressure is force per unit area. Therefore, F1 over A1 is equal to F2 over A2. It gives F2 is equal to A2 over A1 into F1. Pascal's law is applied in following cases.